Okay folks, we're still dealing with vertical translations or changes to the mother curves of sine. Okay, the mother curve for any of these two graphs is going to be y equals the sine of theta. So remember what we said, know the points. Zeros there maximizes, zeros minimizes, and it's zeros over there. In the negative direction it would continue in the same fashion. Okay, so the mother curve for the sine from minus 360 to 360 would be this graph that I'm drawing now, currently. Now that's how you should know your curves, folks, to do this work as quick as you can. I'm not interested in that. I'm interested in the sine curve plus 2 and then twice the sine curve. Both of these affect vertical changes. Remember, this here is a vertical translation 2 units upwards, and here what am I doing? I'm taking all the y values on the sine function and I am multiplying them by 2. So the values on the sine curve will double. Okay, so you can see that that's most probably going to cause a vertical stretch, which is indeed what's going to happen. So let's quickly calculate the points or transform the mother curve to this to represent the graph, which is going to be drawn in pink. So here we have a naught for sine, plus 2 will take it to 2 up there. Here we have a 1 for the sine of 90, 1 plus 2 will then be 3. Here we have sine of 1 is usually naught, we add line over there. If we here at minus 1 and we add 2, 270 minus 1 will land up at that point, and here we need to add 2 to the 0. Now I'm going to change this from naught, let's go the whole way. Let's go minus 360 to 360. Remember, this is the domain of the curve. Okay, so that fashion will continue here. There's a minus 1, we add 1, we add 2, we get to a y value of 2. Remember, it's a vertical translation of 2 units upwards. Here the y value on the curve is naught. Okay, plus 2 would take it back over there. The y value of 270 is 1, plus 2 leaves 3. And here it's naught plus 2 to take me back there. Now just quickly curve your way through those points. There we go. You can see the amplitude of this curve has not changed. The amplitude, folks, don't get it wrong, the amplitude is not 3. The amplitude is where the rest line would lie. Now the rest line has moved up, which was the x-axis, by the way, moved up 2 as well. So the rest line lies over there. And the maximum distance that this curve is away from the rest line is still 1. So the amplitude of this curve did not change. Okay, the amplitude is still 1. Now let's go back to the mother curve and let's sketch the second curve, which I'm going to do in green. What does the equation tell us to do? It says, look at all the y values and double them from the mother curve. The y value is naught here. If I double naught, it stays naught. The y value is 1 here. If I double 1, 1 times 2 gives me 2 over there. Here the y value is naught, and naught times 2 is still naught. The y value is minus 1, multiplied by 2 comes down to minus 2. And then again we have a multiplication of 0 there. So everywhere where we're on the x-axis, the points remain, because naught times 2 is still naught. Whereas with the translation it was naught plus 2. Okay, so we go to minus 1, we double it, we get minus 2. We go to where the curve is a maximum of 1, we double that, and that is where my new curve lies. So if I try and draw as smooth a curve as what you can, folks. Okay, try and keep your hands steady through these points. It optimizes there, it goes through the 0, it comes to the minus 1, and then it moves back to naught. So The green graph represents a doubling of y values. So if I look at the amplitude for this curve, remember it's the horizontal line did not move, the line of rest of this wave, the sine wave. The maximum distance that it is away from the line of rest is 2. So the amplitude for the green graph is 2 instead of being 1. For the pink graph, remember there lies your rest line. Okay? The maximum distance this goes away from the rest line is 1. So the amplitude for this curve is still 1. The period for the curve did not change. Look at the sine curve. That's one full cycle. It's still one full cycle for both of them. So my period here is still 360, and my period for the pink one will also still be 360. Okay, so that did not affect a period change. It affected an amplitude change when I multiplied with it, with a number a, or 2 in this case. If I add 2, it doesn't affect the period, but it does affect the maximum and minimum values. Here, if I times by 2, it affects the maximum and minimum values as well. It does not affect the roots. The roots are still on the horizontal axis of this curve, whereas this curve, the pink curve at the top, will never equal 0 because it doesn't cross the horizontal axis. So there are no roots at the top. But you can see clearly the maximum is 90. The x values did not change. The y values changed. So instead of being at 90 and 1, on the pink curve it's 90 and 3 because we added 1. Here we doubled the 1, so the maximum on the green curve will be at 90 and 2. And it's basically taking the sine curve and stretching it there. Here we're taking the sine curve and we're translating it upwards 2 units. So that is what happens if I add 2 to sine and if I double the sine of theta. Both of those are vertical changes and does not affect the period of the curve. Okay, folks, I'm going to, in the next video, ask you to watch the first 2 minutes and then pause the video, do the work, and then play the video for the memo.